In this lesson, we'll learn some vocabulary that goes along with differential equations, and that vocabulary is so if we say A varies jointly with B and C, we would say that, or we could say A equals B times C, and then we have a constant here, constant of proportionality. So A varies jointly. If you see jointly, it would look like this. A is proportional to B, or A varies proportionately to B. We have that. Inversely proportional to B, we would have 1 over B, but we also need that constant of proportionality. So inverse proportion, we have that. As B increases, A decreases. That's the inverse relationship. So then we can use that vocabulary to write differential equations. The rate of change of x with respect to t is proportional to t plus 1 find x as a function of t. So rate of change of x means dx dt, or can be written as dx dt. With respect to t, rate of change of x with respect to t is proportional to t plus 1. Constant of proportionality, and now we have a differential equation. Separate the variables and integrate. K is a constant, we're just integrating with respect to t. So here we have an x, and then k, t squared over 2 plus t plus c. And that's, we can leave the equation like that. We've written x as a function of t. Let's do the same thing with this. With respect to x, the rate of change of y with respect to x varies inversely with x. All right, pause the video and try that one. Find the differential equation and the solution. Rate of change of y with respect to x, so that's dy dx, varies inversely with x. So we have k over x, and now we separate the variables and integrate. So we get y is, and this k could be on the outside, we have 1 over x, so that's k ln x plus c. the rate of change of p with respect to n varies jointly with n and p. Pause the video and try that one. Rate of change of p with respect to n. Rate of change of p with respect to n jointly with, so we have k and then n and p. Then separate the variables get the p's together and the n's together. Then we will integrate. That's 1 over p, so we have ln p. Here we have kn squared over 2. And we could write this as e to the ln, so that's going to be just p. This is going to be e to the kn squared over 2 times e to the c. So when we have an exponent that's a sum, we can break that up into e to this times e to that. So that's pretty common. We need to be used to that. And then let's write this as c1, and that is c1. Because e to the c1 is just some other constant we can call c, and we can just put it in front. So ce to the kn squared over 2. And then with that absolute value, we can write it as ce to the kn squared over 2. C can be positive or negative, so we don't have to write the positive or negative. But I see it on the solutions for the AP test, so why don't we just put that in there. Okay, let's do the same thing here. Pause the video, try that one. Rate of change of n with respect to t. dn dt is proportional to n. Separate the variables. And integrate. So we move the dt over. The k can stay there. N goes with the dn. And that's 1 over n, which is ln, absolute value of n. And here, this would have to be kt, because the derivative of kt is going to be k. So that's a way we could check to make sure that's the antiderivative. And then we run into the same situation we just had, where we can exponentiate with base e, absolute value of n, e to the kt times e to the c. Let's make it c1. And then e to the c1 will just be c. And this is the same as the familiar formula a equals pe to the rt. So a constant e to the kt, a constant e to the rt. So we can see that this formula comes from a proportional rate of change. So the rate of change of something with respect to itself is where that comes from. Let's just do a differential equation. Practice that. Okay, so here we want to write this as dy dx. And we want to separate the variables. So dy, let's divide by 1 plus y. Dy over 1 plus y. And then we'll multiply by dx. And we have x dx. So we separated the variables and now integrate. Here we would do substitution, but since the derivative of this, if we say u equals 1 plus y, du is dy. So with substitution, we're just going to have the same thing, 1 over u, and then 1 over u du. That's why this is not going to make a difference, and we can just say that the antiderivative is natural log 1 plus y, and here we'll have x squared over 2 plus c. And whenever we have that natural log, we can exponentiate x squared over 2 times e to the c. Let's call it c1. And then this can become some other constant, c. It is some other constant. We can represent it as some other letter to represent a different constant. So if we get rid of the absolute value, we have positive or negative, and then we could move the 1 over. Okay, pause the video and try that one. Y prime is dy dx. So we have dy dx, and we have to be able to separate x and y. So in this case, we're going to move the x and y over. And now we can factor the x out, which allows us to separate x and y. Because now I can divide by this factor that has y, and I can leave the x there to combine it with the dx. dy over 100 minus y, and then we have x dx. So we know the derivative, we know the antiderivative of that. Here, if we did u equals 100 minus y, we have du equals negative dy. So we just have to make sure that we put in a negative when we do the antiderivative. So I'm looking at the antiderivatives. So when we do this one, if we had 1 over u and then dy is negative du, that gives us that negative. So it's going to be negative ln u. And on this side we have x squared over 2 and just substitute for u. 100 minus y. And let's move the negative over to the other side. So we have, we'll call that C, C1, C1, and then we're going to go multiply both sides by a negative. So it'll be a positive, a negative, and we'll call that C2 just because I multiplied by a negative. So C1, and then this is negative C1, but we don't really care. We're just going to say it's something else other than C1. It's just a constant. Then we can exponentiate e to negative x squared over 2 times e to the C2, because it's e to that whole expression as the exponent. This is just some other constant c, and we have a positive or negative. Positive or negative, c e to the negative x squared over 2, and then we'll isolate y. So we have, this will be minus 100, but then we're going to divide by a negative, so it'll be a plus 100. And there's just one other type of problem that is in this section. You don't need to use calculus to solve it. It's just a review of pre-calculus. Radioactive element And the reason why we don't need calculus is because we just have this formula. But if we didn't have this formula, we could use calculus to find it. We've already found that, or PE to the RT, whatever constants you want to use. But since we already have that memorized, then this problem doesn't require a calculus. But this comes from saying that the rate of change of y is proportional to y. And when we have the rate of change with respect to t, the rate of change of y with respect to t is proportional to y, this leads to that. And we saw that earlier. So why don't we just look at, we do have a lot of information here, and let's just look at some points on the graph. Half-life is 1,000 years, so we know after 1,000 years half the amount would be left. After 20 years, we know there's 61 kilograms, so it's doing something like this. Find the initial amount. We need to find out what that is. And we can do this. We have the point 2061, and we have the point 1,000, 1/2 of C. So C is the initial amount, and so we have 1/2 C is equal to CE to the K times 1,000. KT, T is 1,000, so now we can solve that. C's cancel and we get 1/2 e to the 1,000 K natural log of both sides. Natural log 1/2 over 1,000. Now we know k, and we could use that over here with this condition. If we have y equals ce to the kt, we have a y value, we have the t, we have c, and then we have k, and then we can solve for c. So the y value is 61. C is the initial amount that we're going to find. That's what the question asks for. K is here, ln 1/2 over 1,000, and T is 20. So now we solve for C, and we're just going to divide by all of that. 61 over e to the 20 times ln 1/2 over 1,000 is C. So C is approximately 61.852. And we'll stop there.